This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Hello, everybody. You have to turn on somehow, let me share.
Oh, I
Thank you.
forgot.
It is October the 8th and 2025. And my year apparently is just going by faster than I realized because we had a friend who is moving and they were having a goodbye for him yesterday. And I stopped by and I said, but I told everybody you can't be leaving because you're not moving till October. And he looked at me and he said, it's October. And yes, it is indeed. So we are on lesson 11, which is curved lines. And I think in a lot of ways, this may be one of my favorite lessons because we cover a lot of hard math ideas in this lesson, but Lee has done it in such a way that they're really accessible. She doesn't take the training wheels off too early in this lesson. There's lots of scaffolding, and so I really think that for a lot of people who perhaps felt some anxiety around Algebra 2, that we cover a lot of ideas in this lesson that hopefully with enough scaffolding that are building your confidence up so that you're ready for when those training wheels come off in a few years' time. As we do every week, we're going to start talking about our flashcards, and we're sort of cycling back through, but restating in different ways some of the strategies that we've talked about for flashcards. So this week, we're revisiting the idea of choosing flashcards that match the lesson. And it's a great way to have your student be involved in the practice by having them find the flashcards that match the lesson, because then they get to go through and compare the lesson pages to the flashcards in order to find the ones that are going to be helpful to them. It involves them in acknowledging where they perhaps have strengths and also where they could use some continued practice. So when I talk about choosing flashcards, I would certainly encourage you to consider involving your students in the choice. One of the easiest decks to look and connect might be the notations deck, because you can go through those notations flashcards and say which were notations we used in this lesson and pull those out and match them to the lesson pages and then practice those notations. You can then also look at computation facts that perhaps were stumbling blocks in the lesson. If you have a student who is in challenge A or challenge B working through complex or monomials and they're stumbling with some of the fractions and simplifying those fractions, then maybe pulling out some fractions cards would be helpful just to help them build that familiarity. Oftentimes our students may have more familiarity with either a fraction notation or a decimal notation. So using those flashcard notations to connect the two together and to see how they're the same, just expressed differently, is helpful. Or you can practice related concepts from the lesson. So if we're working through this particular lesson where we're looking at power functions, if we go and we pull out notations or computations that are related to powers, exponentiation, logarithms, those might be a good opportunity to go and practice some of those and build up some confidence both in the notation and the laws that are related, but also to practice with numbers. So as we look at this lesson, there's a lot of symbols, a lot of variables that may feel overwhelming to a student who isn't confident or familiar with that notation yet. And so by using the flashcards, we can practice some of those ideas with numbers so that we become more familiar with the idea with numbers in a concrete way. Then we can come back to our lessons and see where we're just using symbols in the place of those numbers. Does anybody have anything they'd like to share or ask about flashcards?
How
I'm
many
glad you said
flashcards?
involve the, oh, go ahead, sorry.
I was just going to say, how many flashcards do people do each day? Or would you recommend maybe?
So there's different schools of thought. I actually read a scientific paper that suggested that if you're really trying to cram, which we're not trying to cram, right? We're looking for long-term memorization, that using more cards and going through more cards quickly is sometimes better than going through fewer cards slowly. But I would think that maybe a mix, that there's going to be times where we're going to go through a lot of flashcards and we're just going to practice them and see which ones you know and which ones you're struggling with. And then there's going to be times where looking at a smaller subset, taking the time to read them, making sure that we can read and connect, that the student actually has the opportunity to learn the connection there and not just practicing. It doesn't help our students if you're showing them a flashcard and they have no idea what's on the back, right? So going a little bit more slowly where we actually fill in that blank or give them a hint. So I think there's a mix. I don't think there's a perfect answer to that, but I would certainly welcome it if anybody else has any ideas that they'd like to chime in about what they do in their home.
Sometimes we'll just have a few minutes and set a timer and make sure that it's done out loud. And so that's really one of the big takeaways that I got from the very, very beginning of exposure to the math map is doing math out loud. And so doing those flashcards out loud, and it doesn't really matter how many, just take a hunk and set a timer for, it could be 5 minutes, it could be 10 minutes. And it sometimes helped at home here for my students not to think that they had to pick. They grabbed the hunk out of the deck, not me. So it was more, sometimes we stick one in that we know they really need to work on. But it was also nice for them to have some times that they just grab, I might even say, just pick 10. Even if they pick 10, they already know. I don't even care. It's still good to review those things. And then I might set those aside and the next day say, you can't pick those same 10. Pick another hunk, grab some. And it was nice and light and easy. There were times that we definitely focused if we needed it, but we have been doing this for a while now. And so even though you've been doing it for a while, if you don't use those notations, you can tend to forget them. And so grabbing a few to review, it's a nice warm up too for the day, since we don't talk about art every day at home. So it is a good warm up.
It's a great reminder, Jill, about saying it out loud. It takes us back to, right, especially for those who are here as challenge only parents now, it's tempting to sometimes forget what we practiced in foundations. But if you think back to your foundations experience, or if you didn't have that experience, I would encourage you to go and maybe watch a foundations morning and see how those foundations tutors lead students through the new grammar, because we talk about you need it 7 times, right? That's what I remember from my days as a foundations tutor, right? We've got to get this in 7 times, which might be saying it, it might be singing it, it might be reading it, it might be hearing it, right? So there's some combination of those, or acting it out. And so using all of those skills that we learned in foundations, the goal is to learn those skills in foundations and bring them with us into challenge, not to leave them behind. So when we're talking about flashcards and memorization, that's the perfect time to say, well, how did you do this, right? How would you have done this and practiced this in foundations? Because we want those students, when they go off to college or to their military training or to their trade school or wherever it is that they go, right? Whatever they do when they leave our home, they are going to have to learn some new set of grammar. I guarantee you, Nobody is going to leave your homeschool knowing everything. And our goal is to make sure that they're equipped with the skills that they need to learn those things that they're going to learn once they leave our homeschool. So if that's memorization skills, because they need to learn. So my son is a new-ish Marine. Right? He had a lot of things he had to memorize as part of his Marine training. So he went equipped to know, how do I memorize this? How do I practice this? Right. One of my favorite stories is that he actually, in his combat engineer school, had to do presentations on different topics. And guess what? He's like, well, I knew I needed an exordium. And so he became one of the favorite presenters because he always had a really good exordium, because he took the time to take his presentations and structure it the way he learned in challenge. So when we talk about memorizing our flashcards and pulling those skills forward from foundations, it's because, yes, we would love to have our students really know mathematics well by the time they graduate, but more importantly, we want our students to be well prepared to learn whatever it is that they need to learn when we are no longer the teacher. Right? And so flashcards, especially for our older students, become an opportunity for them to take those skills and practice them. Babs, you were going to say something.
I was just going to say, I'm glad that you mentioned including your students in choosing the flashcards by lesson, because I see a lot of well-meaning parents and tutors making lists of notations they see. And while that is maybe beneficial, the fact that if they just use the math map over and over again, they're going to see those notations. So you don't have to capture them in booklet 2 or in booklet 4, right? So it's okay if you don't do exactly what they say. Like, I saw it here, so I'm going to do it here. But I liked letting the students choose, because even in my Challenge A class, my kids will say, oh, I saw that in the notation flashcard, right? So I don't even have to point it out. They see it probably even before I do. And then we also have to be careful of copyright, because, right, those math symbols are not copyrighted, but the flashcards are. So you can't scan a picture of the card and then make a document and then share it with everybody on the internet. And so we just have to be careful if we are creating things like that, to just make sure we're not copying the exact definition that we came up with in the math map, and that we're not copying the card itself, and just kind of being careful of that. So if you let the student do it, you don't have to worry about, running into those kind of things. So I just thought I would kind of throw that out. And I think it is good to let the student, because then it's stuff that they notice. It's not stuff that you want them to know. It's stuff that they already notice.
Yeah, I
That's
was
great.
gonna say, and I'm sorry I can't get my camera to work, but I initially had my students just look at the I2 and I3 pages and pick out some grammar that they didn't know and would make their own flashcard. And it was really cute because when we were talking about subsets and supersets, that symbol, like, I wish I could show you, they turned it into a Subway sandwich so that they would remember what that meant. And then the superset, they turned that into a cape because the curve goes in the opposite way. And so just them creating their own, like picking something that stood out to them and really being creative with it, was a fun way to do flashcards, even though we didn't have, because at the time, some of the flashcard sets were sold out. So we're like, well, we're going to make our own. So, yeah.
Oh, I love that. That is really fun. And what a great reminder that you do not have to use these flashcard sets, right? We created them because people like having the ease, right? I confess, I bought Latin flashcards because my students weren't always good at making them. But guess what? It's better if you make your own. So that is an excellent point, that having your students make their own flashcards is really valuable. And I love the fact that they were creative. And I also want to point out that this works for younger students too, right? You can just lay out your, you could perhaps stage this ahead of time so it's not quite so overwhelming, but you could pull out some cards that you know are going to be in that lesson, and then open up the booklet and ask your student, can you find cards that match things you see on this page? Right? A 4-year-old, a 5-year-old, a 6-year-old can do that, right? We're just looking for things that look alike. And so we can do this with our youngest students in terms of matching and finding those, and then we're going to practice the flashcards, or with our older students who are now becoming more involved in choosing how they're going to learn. So, but I'm going to always think about Subway sandwiches and Superman capes now. I really enjoy that.
Yes.
So on our first day is when we come back and we open up to our art and take a look at our covers, not just our art, but our quotations and our reflections. With our older students, that may be somewhere that you dive a little bit deeper. With younger students, maybe the art is a little bit more accessible, but they're there for everybody to use. And so we really encourage you as a family to make sure that you don't get sort of stuck on just one piece of the cover. So this week we're moving on to our common topics, our not our core habits, our common topics of invention from the art of invention, and looking at unfamiliar words, right, on the cover, and then defining those. Might seem to be an obvious thing, but that's what definition is, right? Is looking for unfamiliar words and looking up the definition. Sometimes picking out words that seem familiar and making sure that we do know the definition is also important. So when we're talking about definition, we can look and say, okay, what are some things that we think we know, or what are some things that we don't know, right? So unfamiliar and familiar, there's value in defining both of those. As we look at our art, that's always a great place to compare shapes. So within the art, do we see some different shapes that are alike or some shapes that are different? Right. We don't really have, we talk about the idea of parallel. It's not really defined for a curved line, but as we look at this, we can see where we have that sense of parallelness between the curves. So there's a great way to discuss with our students, what does it mean if we say these curves are parallel? How do we take that meaning and apply it to something that may not be formally defined? And then I thought a really fun circumstance question to ask your students is, what is happening outside the borders of the image? Right? What do you think is just on the right-hand side of that bridge? And there's an opportunity for your younger students and your older students to also practice storytelling, because now you could be thinking about what makes sense that it might be there on the outside edges of my image. And now, why would you pick that? What story would that fit in? If this was a story, what's the setting? And so what's going on either side? What would you choose? You could ask them what the elements of the art represent. So we have curved lines as our title. So our students may just see that that art bridge there looks like curved lines. But then we could also say, well, what about a bridge? Right? If we are familiar with the lesson, right? So this is maybe a question more for older students. We could talk about how the bridge can be an image of a function or a relation. And so that's our relationship question, right? Because it's this idea of it's connecting two different pieces and forming that relationship. And then we could ask them what elements of the cover reveal an authority either in mathematics or in life. So some of that may come from the quotation or the reflection, but just asking them, right? Where do you see some kind of a truth? When we think of authority, sometimes that may be a place to talk about truth. Where do you see something that's true on the cover? Because truth is a type of authority. Any questions about our covers for this week?
It's not really a question, but so I work with, big kids in CC and I live with big kids, but I work with preschoolers at church. And just hearing you talk about the simplicity of looking at the pieces of this with young children, with the kids at church, you really, or at home if you have little children, you could make a bridge or lay down some poster board and call it a bridge and you walk across it. And so kind of getting very tactile with some of them. I think these covers can give us some of those ideas. They can give us ways to play, like the rabbits. Maybe we get out all our stuffed animals, or maybe with the curve, we walk across a bridge and we do math across a bridge. So I think that this art is something wonderful to look at, but it can also give us physical things to do to enjoy math.
It's always good, even for our older students, right? Sometimes movement is really helpful. We had that conversation with somebody recently that if you're starting to get frustrated and you keep working, probably learning has stopped happening, right? If you're frustrated, your brain is not really processing anymore. And so learning has stopped. So break the cycle by getting some movement in. Walk around the house, go shoot some basketballs, do some jumping jacks, right? And so get rid of that frustration in a physical way and then maybe come back. Or maybe that's when you take some of these questions, some of these things to think about, and you act them out in different ways. So I think it's a great reminder to incorporate movement.
I see so many things in the math map that correlate to analogies in Challenge A, because this morning, or maybe it was yesterday, somebody asked about the ratio and like, how do you say it? And the only reason I knew is because we just did ratios, or we did like comparing this is to this as this is to this, and we did it in the analogies book in Challenge A. And then here for like curved lines, and we're talking about the bridge, when we compare those things, we have a little bridge box above it and we put how they're related. And so I don't know, I just think it's cool that analogies, which is not something I would think of to really be directly connected to math, but I've already seen two like in 1 week of how they are related. So I think that's just cool to see.
It's a beautiful integration, right? That when we think about, I think it was really Dorothy Sayers who was really, right, emphasized how we had done our students a disservice by fragmenting their learning. And one of the ideals and goals of classical learning is to integrate learning and help our students to see that they're not siloed, right? That we're working together. And so that's great, Babs. So also on our first day, we take some time in order to know where we are. And so putting our check mark in our math map, showing that we are in lesson 11, reviewing that means that we are in 2D, which is where we're generally taking a look at things from a geometric point of view. That's one thing that the math map does a lot of, is connect the arithmetic to the geometric through algebra, right? So we're looking at graphs, which are a geometric shape based off of an algebraic expression. So we're looking at both there, even though that we call this geometry, we're using that in a very broad sense to talk about visually seeing things that are happening. And so we're integrating that idea of algebra and geometry here. And then our lesson pages. And so we've been talking about all of these different strategies for the lesson pages. And today's strategy, again, wanting to really encourage families that this curriculum is very tailorable, and we know that for many families who are in the first year or two, that tailoring may be that we're doing fewer pages, we are changing the order of pages, that we're emphasizing notation flashcards over some of the calculations, right? So we may be narrowing the focus for newer students, but especially for those students who have had some years of familiarity that are growing, we can take and push them deeper as well. So we want to make sure we understand that there's a whole range of ways that we can use these lesson pages to really encourage our students to work at their potential, whatever you as a family determine that is for a particular week or year, that we can encourage them to work to their potential. One way we can do that is by having them take a look at the lesson page and they themselves go and find that concept on the chart. Right? Can they match what they're seeing on the lesson page to a concept on the chart and then practice reading the chart? So for all of our released domains so far, the charts are there as a reference, but probably with the expectation that it's more for parental reference or parental guidance than for students. Somewhere in Challenge B, Challenge 1, Challenge 2, we would expect that to become more for the student's reference. But asking your students if they are really feeling familiar and confident, well, go see if you can match this to the chart, right? Can you find that content and that concept on the chart and read about it there and see what you're practicing here? And then that brings us to our page 1. Does anybody have any questions about the math that you see here on page 1?
I think down the bottom, the digits looks much more familiar with the pictures than when you get down to when you go all the way across to monomials and there's no pictures. So I really love the pictures at the bottom of the integers, I guess is which one it is.
Yeah, and that's a great reminder, Babs, that if what you're seeing in monomials is feeling very unfamiliar and you're really not sure, that going back and comparing to other domains, which if you have multiple students, you can go and look at multiple domains by using the booklets you have for different students. But as a parent, you also have access to the companion, and you can go and see any of the other domains digitally that might give you that little bit of a hint as to what you're supposed to be doing. So you do have access digitally to see all of those different domains if you're trying to figure out how to step through a concept. One thing I really want to point out, because I want you to look as we look at each of these pages, is I really want you to look at this top section. And you're going to see here, right, that page 1, we're looking at the exponential function, and we're looking at it on fractions, and we're looking at it in monomials. And the big idea for this lesson is that every algebraic function has a matching graph. And you're going to practice that every single day, that every algebraic function has a matching graph. And over time, our students are going to become familiar and be able to match those graphs to those functions. And that's really the big idea for this week, that if your students can recognize that every single algebraic function has a unique graph, then I think that's a huge win. I just want to encourage you that there's a lot of math concepts in this lesson. That's the big idea that we're looking for our students to get. So looking at day 2, we're looking at our I² invention page. And so when we are looking at our invention page, remember that our goal is to practice our common topics of invention. And this week we are up to authority or testimony. So some things that we can look for in order to practice that are looking for things that are laws, properties, or definitions. Sometimes it will say this is a law. Sometimes it will say this is a definition. Sometimes it will say it's a property. And sometimes we may just have to look at the context. So, for example, if you look here at this top section, the context is going to help us to see that we're giving some definitions or some laws, depending on what you want to call them, right? Because we have a heading, constant, and then we have an expression or an equation, variable. So that is something that's maybe going to be something we can see as an authority, right? It's telling us what do these words mean. It's defining these. We can also look for relationships in which one value or variable is an authority for another variable or figure. So we may see something about limits, right? So when we read a limit, right, so here, what X is doing, right, becomes sort of that authority for what the function of X is doing. Right? So whatever, in this case, if I say X approaches 4, well, that is now my authority. That's giving me, this is the context or the rule for this particular expression that I'm looking for. And then I think a general question, so those two maybe feel a little bit more mathematical. And a more general question that you could ask your students is what's familiar on the page? We haven't talked about that a lot, but that's always a great question for this page. Is just to say to them, what's familiar? Right? What might you have seen before? What's familiar? And then discuss how familiarity is a testimony to the previous work that you've done. Why is it familiar? Things are never familiar if we've never seen them, right? So being familiar with something, knowing something, is always a testimony that I've seen it before, that somebody's defined it for me before, that I've practiced it before, that I saw it through practicing flashcards, or that it was in another lesson and I've done an exercise. That familiarity is always a testimony to previous work that we've done. And so talking with students about that, we were studying Hebrews 11 last night, and one of the ladies in our group said that our faith is built by evidence, right, that we've seen in our lives. When God has been faithful to us, that encourages our faith and our trust in him, right? So our faith in some ways, as they look back, is a testimony to God's faithfulness. And so our familiarity is a testimony to the work that we've done. And that's an opportunity to encourage our students, right? Look, you did this work and now it's familiar. So if we keep doing this work, more things are going to be familiar to us in the future. Any questions about our invention page?
Not necessarily a question, but I'm glad you brought up familiar again, because at the top of the page where it has read as, I know I've seen that before, because I remember the first time looking at it thinking I don't know how to read it. And so I know I don't know if it was in the naturals or if it was just in a previous lesson, but I know I've seen read as. And so that's something that I would point out to my students, because that's something that was familiar to me, is that, hey, if you don't know how to read it, it's okay, because it is at the top of the page, but we've seen this before, whether it was just practicing in the naturals or in these lessons.
Yes, I also appreciate the read as. I noticed when I was in the rationals, I have one student in the rationals and one in complex, and it was nice to give that direction to my complex student who just saw the expression without the read as. So I looked over, because we're trying to do it at the table together. I looked over at the rationals booklet. I said, here's how you read it. And it was so helpful to have that. So I just wanted to say that's another testimony that it was super helpful. And also my computer is about to die. So if I suddenly drop off, I apologize. I'm not trying to be rude. I appreciate this so much. So thank you for all your help.
Well, we're glad that you're here for as long as you're able to be.
Thank you.
So let's look at page 2. Again, I'm just going to point out to you, if you look at the tops here, right, we're looking at the same, right? We're looking at the constant function with our youngest students, with our integers, but notice that constant function pops up with our older students. And then notice these graphs, right? We're practicing these graphs over and over and over again because we really want students to become familiar with them. So the first year, the second year, we may not be getting there, but over time, students are going to continue to look at these graphs, connecting the idea that there's an algebraic expression, there's a geometric image, and that the two go together. Are there any questions from the content on these pages you'd like to talk about? All right. So day 3, we look at our I-cubed memoria and arrangement page. This is your opportunity to practice those core habits of memoria. And so we are on the M for memorize this week. And so one of the things that we already talked about is finding content in flashcards, right? So if we look at this page, is there something here that may also be in a flashcard? Now, this particular lesson may not be, there may not be a lot yet, but we are working on completing flashcards that are going to perhaps bring some of this in, right? So we're working on, for example, the sine, cosine, and tangent. Right? We may have flashcards out next year that you could do that. But this is a great time to talk about making your own flashcards. If you have students that are wanting to memorize some of this, right? If we don't have content in the flashcards, making your own flashcards, because that allows us to practice that through drill and games. We can look at the context, right? So if we, again, looking for, our row and column headers can give us context. So then what is it when I multiply this information here? What is it that I'm memorizing? Well, I'm memorizing a power function. I'm memorizing the name of the function, the graph of the function, and the general equation of the function. So I look at that context in order to figure out what can I conclude in my memoria. And then I can always ask the question, what must be memorized exactly? So if I'm memorizing general equations, or in this case, the reflection across y equals x, which in many of these cases is the inverse, but not always, which is why we chose to call it the reflection across y equals x. Right? Those are some things that we want to memorize exactly. Right? Saying, well, the reflection of a line across y equals x is y equals like x something over something plus something isn't really helpful, right? So there are times when making it more general, memorizing words instead of symbols may work. But in this case, we really want to be exact. And so asking our students what looks like something we really need to memorize exactly. Then asking what are the patterns that might help us to memorize. So we might say, okay, well, if I look at the left-hand side and I've got these groups, maybe I know that I'm going to look at these as groups instead of looking at them individually. So by grouping these, I see some things that are similar between them. What are some things that are similar? Okay, well, these are all trigonometric, so maybe that helps me. Seeing those patterns is going to help me to memorize. And then, where have you seen this? Have you seen it in another lesson? Have you seen it in this lesson? Right? Where could I practice recalling the information? Did you see it in a chart? Right? Where else have I seen this? And I just want to make the mention that we do anticipate or expect that students will learn something in booklet 1 or 2 or 3 or 4 and still be using that in booklet 11. Right? So the booklets, though you can not have mastered something and then move on to the next, right? And look at the content, that there's a certain amount of standaloneness to each booklet. Sometimes we do have people that are like, well, where is it? Where is it explained in this booklet? Or where is it explained in this chart? And there are things that are going to be in previous booklets or previous charts that need to be pulled forward. And so we do try to help with that somewhat in the companion, not always perfectly. But if you're looking for something, if you're looking, well, where did they teach that? And you don't find it in that lesson, it may be worth going back and scanning through the charts from previous lessons to see if you find it there. And also to help you with that, if you look up something in the glossary does have chart references. So that'll help you to go and identify what lesson an idea came from, and even perhaps get a sense of which chart it was on, and therefore which pages, maybe to look for some sample problems. Any questions about memoria and arrangement? So here's day 3. So again, notice here we're looking at the rational function, and what are we doing? We're looking at rational functions. So we're taking a deeper look now at these functions, specifically the rational function on day 3 across all 3 lessons. Are there questions? And you'll notice, right, that Lee is in the middle section here, right? She's connecting the idea of ratio to rational function. So where she's trying to help students to make those connections. Which brings us to day 4 and our careful calculations. We had a conversation with somebody earlier who asked us if just using the careful calculations as an assessment at the end of every week was enough. Would they see all of the major concepts? And we want to be clear that you will not, right? That it is intended to be related calculations. In this case, if you look at this page here, it may be less sort of calculation and more in terms of simplifying those equations. But the goal here is to take a certain subset of the material for that week and practice it in a different way. One of the ways you could do that is to use this as daily computation practice extensions. So you could take this page and look at calculations on this page and say, well, where was this introduced or practiced in the lessons? And so on that particular day, if I'm looking for a little bit more practice, I might say, okay, go do this portion of the careful calculations. Right? I could also do that, right, and match the calculations to the chart where the concept is generally stated. And then I can use cards, right, or our memoria and create additional exercises. So that's one way that I could take this instead of using it on day 4 and break it out and use it a little bit each day. Any questions about careful calculations? And
What
so
does
here we
parent,
are. Oh,
sorry, what does parent equation mean on monomials?
sure. So when we think about functions, a parent equation is the simplest form of the equation. And all other related functions, so I'm gonna draw, let me make sure I have my pen on. So let's talk like y equals x. We say that that is the parent function of all lines. It's the simplest case. My slope is 1 and my y-intercept is 0. Every other line in 2 dimensions is going to have a y and it's going to have an x. Now we can write it the way that it is here, but I'm also going to relate it for most of you, you're probably familiar with, right, that there's a slope and the y-intercept. So all of my lines are going to be related to y equals x. So I like to think of it as they're the parent. Right? So if you're the parent, you're the starting point. And then, right, you have children, and your children are going to have some of the same characteristics as you. Right? They may share a last name, they might share an eye color, they may have some habits, right? There's things that identify them as being a part of your family, but yet they're unique. And they're, right, they all have a little bit of a different slope. They may all hit the y, right, have a little bit of a different y-intercept, but we know that they're part of your family. And so every other line, right, if we graph it, it doesn't matter if it's got a negative slope, if it's got a positive slope, if it's got an infinite slope, a 0 slope, no matter what that line looks like in terms of its slant, its location, we know it's a line. And so that's why we call it a parent function. It's the very simplest case. And then all of our other functions are built off of that. And in lesson 18, that's where we say, well, that parent function could be rotated, it could be reflected, it could be translated, it could be dilated, right? We can do all of those things, but we know that a quadratic function, no matter what I do to it, it's quadratic, right? That's the essential part that I don't change. So, does that help?
Yes, thank you.
So looking at page 4, we're looking at radical functions here. These are all power functions. So on day 1, we were looking at the exponential and the logarithmic functions, which are not power functions. But day 2, 3, and 4 are all power functions, and they all behave in very similar ways. And so we're going to see these power functions. We're going to see them here in lesson 11. We're going to review the graphs in 17 and 18. And then we're going to see that there's behaviors in 25 and 26 that are true for all power functions. So I just think it's really cool. And then if you look back to how we defined powers back in lesson 7, right, we see this beautiful connection all the way through. And so I won't get on my soapbox because I just think it's really cool. But that's what this lesson, the emphasis in this lesson, you're going to see most of the emphasis is on power functions. And so it's an opportunity to go back and review that grammar. What do we mean when we talk about powers and exponents and roots and so forth? Any questions on this page? Although it looks very algebraic and it looks like there's a lot of notations, I really just want to pull your attention to the fact that most of it is reading. It's looking at an expression and pulling values out just by matching. And so it's becoming familiar again with that language of mathematics, specifically for these functions. And that brings us to our reminder of all the support that we want to offer you through the companion, the forums, in your community, right? The beautiful goal that we are united in mathematics in our community through your challenge tutors. We know that our essentials tutors are bringing some of this into essentials. So we're excited to see all of our community, right? The entirety of our community from foundations through challenge being able to be united in a math conversation in a way that's never really been possible before. We're here every Wednesday at 1, so if you are watching the recording and have the opportunity to come and join us live, head over to leebortons.com and click on that link at 1 o'clock on Wednesdays, and we would love to have you here sharing your insights or asking your questions. So please know that you are always welcome. There is no special requirement to come and join us. Everybody is welcome to come and be alive. If you are looking for something specific, we know that there's a lot of content here, and I don't think that I would recommend to anybody that you start with video 1 and try to watch all the way through. And so we've heard from people that say there's so much. It is fine to just pick up where we are now, to come next week and watch lesson 12. Pick up where you are. If you have a friend who says, I don't know where to start, pick up where you are. Or if there's something specific that you're looking for, if you email the math map at classicalconversations.com, Babs is amazing because she can tell you, hey, these are the 3 book clubs that are going to be the most helpful to you, or go and watch this, right? This series is going to answer these questions. So I really encourage you, if you're looking for something specific, feel free to email us and we will be happy to help connect you with your best episodes. And it is okay to just jump in where you are and move forward. And then as you become more familiar with the flow of the book club, you might be then able to determine for yourself, I want to go back and look at this particular episode to answer this question. And then that gets us to our question time. And so you are welcome to ask any questions from this week or last week or the week before or any of the weeks that have gone before. We are happy to answer your questions.
Okay, well, I just want to say, yay, I made it. I think I have 2% left, but I'm hanging in there. So I wanted to give a shout out to Babs because I just spoke with her earlier this week about a question I had, and she took me to, I think, week 2 or 3, the chart with the eyes, the imaginary numbers. And so, yes, Babs, I am that person. And that it was an aha moment for both of us. And she was like, she made a little cheat sheet. She posted it in the chat, and it was just exactly what I needed. So thank you, Babs, for your help. And then all the other questions that, sometimes you're like, this is silly, and you feel kind of silly for asking, but I've emailed and had great responses. I think recently from you, Dr. Gilpin, which was great. And sometimes you just need to ask the question and then do something else and then come back to it. And it's like those words, they finally made sense to me, even though I just couldn't get it before. So anyway, thank you both for your help.
Oh, you are so welcome. Yeah, we are not God. First, I want to just say that, right? We are not God, but I love the verse in James where he says, if any of you lacks wisdom, ask of me and I will give it generously without criticizing. And so God is our model, right? He is who we are patterning ourselves after. And so if God welcomes your questions and your request for wisdom and he doesn't criticize, then neither will we. And so we may not always be able to give you the wisest answer the way that God would, but we will do our very best and we never criticize. And so please, we want everybody to know there's no stupid question. There's nothing that you should know. You are welcome to come and ask any question that you want, and we will do our best to help you gain the wisdom that you need.
Thank you.
I have lots of questions.
Great. Like questions.
Fractions, book 8, page 12. In the top left-hand box, working through vectors, and I I assume at some point vectors will be something that I will understand greatly, but I'm still in the grammar stage. So I greatly appreciate my child going through the fractions because it's at a much more approachable level than the monomials are with my daughter. But specifically like the second one where it's like 1/3 inch compared to 1/3 inch with the vector, one vector going to the left and the other going to the right. Since vectors are just magnitude, like the fact that one's going left, one's going right, that really doesn't matter because they're both going 1/3 of an inch. Am I reading that right?
So yes, I think that this may have been edited. So Babs maybe can tell me because I'm thinking that this has actually been edited to show like the magnitude here. So vectors normally have distance and direction. So they have magnitude and direction. And so in order to compare them, we can compare, you can't really compare direction, right? There's not a greater direction or a lesser direction. What we compare is their magnitude, which I think you see in the first two. And I think that, I don't know if, I'm just gonna be honest with you, I don't know if Lee has added those absolute value symbols, but that's what she's trying to say is we're really comparing the magnitude and not the direction in this case. So if it helps to sort of think, oh, wait, we're still talking about magnitude, even though these are illustrated in this different way, we're still talking about magnitude. We're not worrying about the direction.
I'm not sure exactly what has been changed, but I know somebody else sent this in and something has been changed on this page, but I can't see the updated copy, so I don't know exactly what's been changed.
Okay, awesome, thank you. And then in monomials, book 8, page 1, I didn't write down where it was, but it's the matching portion on that page. I had a question as to why factorials went with limited by argument is greater than or equal to 0.
There, because of the way the factorial is defined, it's always defined, right, as the product of 5, 4, 3, 2, 1, and so forth. It's just not defined for negative numbers. So it's just mathematicians, when we defined what that meant, it was always numbers greater than or equal to 0. Now that said, if you're right, we do have this question here where we have sorry, I just noticed that my chat box is like in a weird place. The right, 0 factorial equals 1. And one of the questions that we've had is why does 0 factorial equal 1? And that's because when I say that, when I define n factorial, it can be defined recursively, meaning that it's n times n minus 1 factorial. And so I can keep going and I can say, let's just use a number, right? That 3 factorial would be 3 times 2 factorial. Well, that would be 3 times 2 times 1 factorial, which would be 3 times 2 times 1 times 0 factorial. And so the only way that this works is if this equals 1. And so for this recursive n factorial equals n times n minus 1 factorial to be true is if 0 factorial equals 1. So that's mathematically why 0 factorial is 1.
Awesome. And then a general question, when do you know that we need to reverse the inequality? This question specifically came from monomials, page 3, book 8. I love how you guys showed it wrong and then showed like that it should be flipped. But is it only whenever you're dividing by a negative number? Is that the rule?
It's either dividing or multiplying by a negative number.
Okay.
Yeah, that's the rule. And the way that Lee shows that there, this is kind of bonus content here because we haven't shown this yet, but we're eventually going to get to something like x squared is less than 5, right? Or the absolute value, right? We've talked about how we can do that, breaking it down. But what we end up here is we say, well, the related, if we looked at x squared equals 5, x is therefore the positive or negative square root of 5. If I was to look at, here's my negative square roots of 5, 0, and positive square root of 5. I have 1, 2, 3 possible intervals that I'm going to test. And so I could say, okay, well, if x is less than negative square roots of 5, so let's say negative 10, right, is less than negative square root of 5. So if I have 10 squared, is that less than 5? No. So it's not, this is not where it's true. If I put 0 in, it is true. If I put 10 in, it's not true. And so I now can go, okay, well, negative square root of 5 is less than x is less than 5. And so I see that it has to go that way. So it's the same idea when I look at negative x is less than 5. If I say, well, what's related? X equals 5. So I can graph my 5. Well, what happened? Oh, sorry, negative x equals 5. I don't know what I was doing there. So x is negative 5. So there we go. X is negative 5. It's less than, it's not equal, so it's an open circle. Now I can test on both sides. And if I say, okay, well, negative 6, well, the opposite of negative 6 is 6. That's not greater than 5. So it's not this side. Let's try 0. Is 0 less than 5? Yes. So it is on this side. And so I see that x has to be greater than negative 5. So it's the same idea that I can always start with where would they be equal, and then graph and test each of my intervals is always a strategy you can try.
Yes, that's what I was trying to explain to my daughter too, but she was like, I just don't get it. I'm like, well, then just plug in numbers. Like literally, that's the best way to do it. If you don't understand why it is, just plug in numbers and figure out which one actually is the right answer. Like which one shows a true statement.
Yeah, and that's the best thing that we can get our kids to do is just keep testing it until you're convinced that it's true. See if you can figure out the pattern. Because we can come up, I can sit there and give you rules, right? But then you're just memorizing a list of rules. But if you can sit there and go, oh, I just see, no matter what I have, I can always do it this way, you're going to start to notice those rules on your own over time.
Awesome. Thank you so much.
Oh, you're welcome. Any other questions? Well, thanks everybody for being here today. Thanks for participating. It really is best when you guys are all participating and sharing your thoughts, asking your questions. We really appreciate that. So we hope we will see you all next week when we're talking about polygons. So it's a great example of how Lee tried to say, okay, the concepts in lesson 11 are hard, let's follow it up with something that's going to feel a lot more familiar and a lot more approachable, which is polygons. So she really did try to build in some breathing space as you go through the math map. And so that'll be hopefully more familiar to everybody and a lot of fun. We'll see you then.
Thank you.